Molten platinum at 1768 degrees Celsius, palladium at 1555, rhodium at 1964. The cylindrical zirconia crucible holds them all as a stable melt pool, releases them as a clean pour, and survives hundreds of melt cycles without degradation. The deep vertical cavity that turns precious metals refining from a high-loss process into a high-yield one. Maximum continuous operating temperature reaches 2200 degrees Celsius, comfortably above platinum's 1768 degree melting point and rhodium's 1964. The matrix is chemically inert to molten platinum group metals across the full melting envelope, preserving the 99.95% purity that defines catalyst grade, jewelry grade, and medical grade refined platinum group metals output. And transformation toughening delivers the thermal shock survival required for rapid platinum group metals melt cycles. Two grades cover the precious metals melting workflow. Yttria-stabilized zirconia delivers the highest thermal shock resistance and is the default grade for high-cycle platinum group metals melting in production refineries. Magnesia-stabilized zirconia handles the most aggressive melting chemistries including molten platinum with reactive flux additions. Both grades hold stable phase structure across hundreds of melt cycles without crucible degradation. Standard sizes cover the precious metals refining workflow, from small assay-scale crucibles for laboratory platinum group metals analysis through to larger production-scale crucibles for batch refining in induction furnaces. Custom diameters, heights, wall thicknesses, and lip configurations are machined from drawing. Both yttria-stabilized zirconia and magnesia-stabilized zirconia grades are available across the full-size range, allowing refineries to standardize crucible inventory across assay, intermediate, and production-scale melting. In precious metals melting and refining, platinum, palladium, gold, rhodium, and high-temperature superalloys handled in induction furnaces and gravity pour configurations. Three things determine whether the melt cycle succeeds. First, the melt pool must stay stable. Cylindrical deep cavity geometry holds the molten metal as a tall narrow column, minimizes rim splash, and preserves expensive material that would otherwise be lost to crucible wall sticking and oxidation. Second, the induction field must couple cleanly. Cylindrical axial symmetry matches the induction coil field geometry, delivers even electromagnetic stirring across the melt, and produces homogenized alloy composition without manual intervention. And third, the crucible must not contaminate the melt. Stabilized zirconia is chemically inert to platinum group metals across the full melting envelope. Alumina dissolves into molten platinum and sheds aluminum contamination, but zirconia preserves the 99.95% purity that determines refined metal value. Together, these three properties make cylindrical zirconia crucibles the industry standard choice for precious metals refining, jewelry casting, platinum group metals catalyst production, and laboratory assay work.